Coding and programming. It's the high-tech fantasy world that many of us hear about but feel disconnected from. The digital witchcraft involved with the programming process means that to be capable of it, you have to be on a level with Neo from The Matrix or future Emperor of the World, Mark Zuckerberg. Right? Wrong. Learning to code, as with anything, is merely a series of steps. Each step on its own is completely manageable. The important thing is to not feel daunted by the end product. If you take the first step and keep going, you'll eventually look back and be amazed by how far you've come. So what actually is coding then? We hear a lot about it, we see it in movies, in the over-dramatized hacking scenes, but what actually is it? It's basically a language designed to make communication between humans and computers straightforward. Well, relatively speaking. Computers speak in a language called binary. Binary is the number system in base 2. All it consists of is 1 and 0. Computers are adept at making vast and complex computations in the binary system, but humans are not on the same level. Our primary communication method is the spoken word, which computers are rubbish at. Imagine code as the bridge between the two. It combines the logic of computer science with the structured language-based system that we all need in order to work well. Code has a strict syntax and structure, and is essentially a list of instructions for the computer to follow. It is used so widely now that everyone relies on it. Just a few of the applications include creating software and video games, controlling phones, cars, planes, even rockets. You can also use it to simulate just about anything. For example, how bacterial populations react to a new drug, something that could help reduce the need for animal testing. Learning the syntax can be interesting, but the best thing about coding is just the range of different things that it can be used for. And even if you don't think you want to become a programmer, you might consider learning the basics so that you're aware of how it works and have the ability to communicate with the tech world later on in life. One thing that has to be said is that you shouldn't bother learning if your only motivation is to become a billionaire, as you can almost guarantee that is not going to happen. The Silicon Valley tech billionaires didn't set out in computing to become rich, although I'm sure they have no objections to it. They got into it because they enjoyed it. And if you want to learn coding, you should do so because you're excited by the potential of what you can do with it. You should see it as your personal toolbox for navigating the world of computers and general tech stuff. You should do it because it excites you and you want to lift the veil on what is often seen as an inaccessible science. So if you're still watching and you want to take the first step, where do you start? Well, the first thing to do is pick a language. There are different coding languages that do different things, and they have different pros and cons. But once you've learned one, the others become easier to pick up. If you don't have a preference, I'd recommend Python. Not that one, this one. It's quite easy to understand and has a versatile range of applications. It is widely considered a good beginner's language. Next, you need to find a learning resource. I would suggest online tutorials and courseware such as Code Academy and MIT OpenCourseWare. Both are brilliant and the relevant links are below. After you've completed that, the next step is to set yourself some projects and apply what you've learned. This can be quite challenging at first, as you're transitioning from a rigid to an open learning structure. Google is your best friend here. You can find loads of websites that suggest good programming projects and walk you through them. There are also a ton of forums that are great for any specific code questions you might have. A real skill is learning how to frame your question and know what you're looking for. Once you've mastered this, you've already won half the battle. From then on, what you can do with your newfound skills is really down to your own imagination. This video is part of an outreach series produced by the Warwick iGEM project. We're a group of undergraduate students working on a synthetic biology project for the iGEM competition held in Boston, USA. If you'd like to know more, check out the other videos on this channel. Also, we've put a load of useful coding resources in the description below, so be sure to have a look at that. Finally, we'd like to thank some of our generous sponsors, the Andrew Little Fund and the Warwick School of Engineering, for supporting this project.